Okay, so the purpose behind this video is to walk you guys through how we do some basic right triangle geometry and trigonometry, for those of you who might have missed it because we decided not to partake in the remote learning that occurred back in the spring. So obviously right triangles, these guys right here, that's not really a straight line, doing the best I can. But this is your basic right triangle, and all of the stuff I'm going to talk about right now is with respect to theta, our angle. Don't get confused with theta. Theta is just an unknown. It's x, basically, for things that deal with angles, right? That's all it's meant to be. So the first thing that we can talk about when we're talking about these right triangles, probably the one that you're most familiar with, is how we get each of our three sides, or the equations we can use if we know two of our three sides, that sort of thing. And so that's going to be obviously our Pythagorean theorem. A squared plus b squared is equal to c squared. Remember that A and B represent your sides of your triangle, and that C represents the hypotenuse that you have. And from there, you guys really should, I hope, have an understanding of how to plug stuff in, right? If you want to find that third side, if it's A, then you've got to move b squared over, square root at the end. If you're solving for C, then just square and then add what you've got in A and B and take the square root at the end. Don't forget that square root part at the end. That's one of the things some people tend to miss. The next part of this, though, is going to be your basic trigonometry. So we're going to have an expression that I've used a lot in class, but you might not have known about it until, obviously, we started doing it in class if you didn't see this in geometry last year. And it's SOHCAHTOA. So SOHCAHTOA represents they basically represent equations that you're going to use for sine, cosine, and tangent. They tell you exactly where to plug things in for each of these. So we're going to have, what the letters SOH represent is going to be sine of theta is equal to opposite over hypotenuse, whatever those numbers might be. Cosine is going to be, cosine of theta is equal to adjacent over your hypotenuse, and then tangent is tangent theta, or the TOA is tangent theta is equal to opposite over adjacent. And so these equations are going to tell you how you're able to actually solve for the individual angles that you're looking for. Or maybe you've got the angle and you've got to find one of the other sides, the opposite side or the adjacent side, or maybe a hypotenuse. So I'm going to walk through a couple of practice problems, a couple of examples using the triangle on the right, so that we can see this applied in at least one of each of the following ways. So I'm going to come up with some random numbers. I'm going to have a hypotenuse of 28 and 21. I'm going to be making the side of my triangle. Now you're probably asking, because we should recognize our hypotenuse is 28 every single time. That should not be something that we have any doubts about. It's opposite the right angle. That's always since junior high, but when we labeled as our hypotenuse. The adjacent side is the side that is next to theta. It's the next to the angle that you're looking at. I could have put theta up at the top, and my adjacent side would have then been the vertical end of this triangle, but instead, I put theta down here in the bottom right. So my adjacent side is the horizontal segment of this, which also makes this vertical portion over here that I haven't done anything with the opposite side, right? It is opposite the angle in question versus next to the angle in question. And then naturally you have your hypotenuse. So that's how you're identifying which one it is you're dealing with in each one of these equations. If in this case we have next to our angle, next to theta, we've got our 21 on the adjacent side and 28 on the hypotenuse, then in order to find that angle, because I have adjacent and hypotenuse, I've got to use cosine. So the generic equation is cosine of theta is equal to adjacent over hypotenuse. I can plug in what I know so far, and this becomes cosine of theta, because I don't know theta yet, is equal to 21 over 28. You could solve this if you really wanted to with 21 over 28. Hit enter in that calculator, and you should be able to get a nice, neat 0.75. But let me rewrite that. You're not done yet. From here, what you found is the cosine of theta is equal to 0.75. That is not theta itself, right? If you type in 0.75 in your calculator, hit enter, you get 0.75. If you type in the cosine of 0.75, you're going to get some other number, right? Cosine is a mathematical function. Sine, tangent, and cosine are all mathematical functions being done on cosine, on theta. So when you go to solve this, you've got to rewrite this in terms of theta, basically dividing both sides by your cosine. But what you'll type into your calculator is exactly this. All right, that 0.75 gets placed in parentheses, and you have your inverse cosine, right? Anything raised to the negative 1 power is basically meaning you're dividing by that thing. 3 to the negative first power is the same as 1 over 3. 10 to the negative first power is the same as 1 over 10. So this is the same as 1 over cosine. We divided by cosine on both sides, but this is how you type it into your calculator. The steps you would do to solve this, to get it in your calculator, because that has been asked, you'll type your second button up in the upper left-hand corner of your TI 83, 84, 85, whatever it is, and then all you've got to do is hit the cosine button. You'll see written up above it, cosine with a -1, in the same color that your second button is written. It will open a parenthesis for you, so you just have to type 0.75. I close that parenthesis because I'm particular about it. You don't have to close that parenthesis if you don't want to. I like to, just in case I have to do math after that. But you should get an angle of 41.4 degrees if you are in degrees. If you didn't get 41.4, that means your calculator is probably in radians, and you've got to go up to the mode button, M-O-D-E, go to the mode button and swap radians from being highlighted to degrees. That's what you're going to need. So that's how I knew in this particular case, in order, how to get the angle measurement that I needed there. We can also solve using some of our trig for that opposite side. We can solve for it using either tangent or sine, because that contains the letter O. I'm going to do both of those actually down here for you so you can see it doesn't matter which one you have. Once you have an angle in 2 of your sides, you're free to use whatever you want. Once you have all 3 sides, you're free to use whatever you want. So I'm going to do sine and tangent with you, show you how to set it up with finding what that extra side should be, and then we're going to confirm all of it with your good old tried and true Pythagorean theorem and make sure it works out to be the same. So I'm going to start with sine. Right? In this case, I've got sine of theta is equal to opposite over hypotenuse. That is my generic equation. I'm going to plug in what I know. I've got sine of 41.4 degrees is equal to, the opposite side is my unknown. I'm going to leave it as O. You could leave it as an X if you really wanted to. In fact, let's do that. Right? That was our unknown. That's the side that we didn't have a value for yet. And our hypotenuse was still and will always be 28. Now, when you want to go solve for x here, you've got x divided by 28, so you've got to undo it by multiplying by 28, not 25, sorry. So multiply both sides by 28. In your calculator, what I would type is 28 multiplied by the sine of 41.4. You don't have to use the inverse sign. You don't have to do the second function here at all. Literally just 28 multiplied by the sine of 41.4. We should get a value of 18.5. And again, remember that's the length of my opposite side. So I'm going to erase x. And I'm going to rewrite it as 18.5. I'll leave it as x equals. That way we remember this was our unknown we were solving for. Make that decimal a little bit more clear. So x is equal to 18.5. We should get the exact same value if we had used tangent instead. But notice the tangent function does not contain the hypotenuse. So if you use tangent, you should not use the hypotenuse of 28. So I'm going to scroll down and we're going to work through that, right? Tangent is equal to opposite over adjacent. So where's my cursor? There we go. I've got tangent of theta is equal to opposite over adjacent. When I fill everything in that I've got, this is going to be tangent of, my angle is still 41.4. The opposite side is what I was solving for. It should be 18.5. We're going to confirm that. The adjacent side was 21. That was the side that was next to our angle. We're going to solve this the exact same way that we solved the last one, right? You've got 21 in that denominator. You need to get x by itself. To undo division, you multiply both sides together. So x is equal to 21 multiplied by the tangent of 41.4. Notice how similar this looks to sine. The only difference is the number that we have out front. That's very important because sine and tangent are two different functions. So 21 multiplied by the tangent of 41.4, close my parentheses, and I still get 18.5. All right, that's cool. The trig checks out. I keep getting 18.5 every time I do this. Let's double check good old Pythagorean theorem, just to make sure that you can still use this. Pythagorean theorem is a squared plus b squared is equal to c squared. I've got one of my legs originally, so I'm going to leave a as my unknown. This is going to be plus 21. That was my b. That was the other leg. Is equal to 28, and I'm going to have it squared. In order to solve this, I'm going to go ahead and square those guys just to get that out of the way. So I've got a squared plus 441 is equal to 784. Subtracts both sides by 441. What I'm left with is a squared is equal to 343. My last step, as with all algebra, when you've got something squared, you take the square root. So the square root of that answer is going to provide me with 18.5. So it doesn't matter, right? I started the problem with 2 of my 3 sides. You could have done the Pythagorean theorem right off the bat and solved for that opposite side all the way off on the far left, right? This vertical end, you could have solved for that right away and then used any of your trig functions, right? Once you solve for it, it doesn't matter which of these trig functions you use, so long as you plug the opposite and hypotenuse and adjacent values in the correct space. 21 for theta should not have been plugged in anywhere you see the letter O, and it should not have been plugged in anywhere you saw the letter H. If we wanted to go back and confirm, which we totally could, that our angle was 41, we could use any of these and find that angle, right? You could do the inverse sine of 18.5 over 28. You could do the inverse cosine like we did to get the angle of 21 over 28, or you could do the inverse tangent of 18.5 over 21. All of those will equal 41.4. So with this trig, with this right triangle trigonometry, we're going to be applying this a lot to the vectors that we're going to be talking about in the next chapter. Basically, the direction things are moving, the direction forces are being applied, or velocities are carrying objects, momentums, things like that. We're going to be applying these vectors. So this right triangle trigonometry isn't going to go away. And this is what you would have been doing, at least at the beginning of those portions of your geometry class last year that you might have missed because of COVID. So I hope that helps. Let me know, please, 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 if it doesn't. And if you want to see any more worked out examples, just message me. I'd be more than happy to come up with a few additional sample problems. Thank you.